Guys, so today we're going to be doing a brief intro on the Aircrack-ng suite. And so all that this is a set of tools that all work in conjunction with each other to do different kinds of wireless hacking. And so I'll give essentially a very quick crash course in the basics of wireless hacking. So we're going to be covering four main things. We're going to be dealing with wireless enumeration, hidden SSIDs, WEP cracking, and WPA cracking. We're going to be using four main tools for this, and that will be Aircrack to do our passwords, Airmon to do our monitor mode, AirReplay to do our packet injection, and airodump to do our enumeration. More on some of those in just a second. So first of all, wireless enumeration. All this is looking out into the air and seeing what's happening. So to do that, first of all, we need to do something called use monitor mode. And so this is a particular mode that we can set our different cards in, and it allows them to listen on the network. It's very similar to promiscuous mode on wire networks. It allows the cards to listen for packets that are not destined for the card. And moreover, it doesn't even need to be associated with any network in order for it to actually work. To do this, we're going to be using airmon-ng, and it's just a tool that easily allows us to initialize monitor mode on our different interfaces. So, I'll go ahead and stop that for a second. Alright, so if I just do simple ifconfig, actually ifconfig tac A, you can see we have WLAN 0 and WLAN 1. So this is my inbuilt wireless card. This is my kind of cheap little $3 external wireless USB adapter that I have plugged in. If we just do straight up airmon-ng, we can actually get the driver and the chipset that's used for each particular card. So first of all, what I always like to do is do the command airmon-ng check kill, and what this will do is we'll actually go through and kill any process that might interfere with us as we're dealing with the stuff. Like network manager sometimes will mess with us, sometimes DH client will suddenly change our IP address, to something we don't want. So we're going to go ahead and kill all those processes. And then, in order to actually start monitor mode on a card, just say airmon-ng start and give it the name of the interface. In this case, we'll use WLAN 1. Alright, so it said it was successful. If we go back to config, we have this brand new interface called WLAN 1 mon, and that's just to indicate that this card has been put into monitor mode. So, we come back here, the next thing we're going to do is use that in a tool called airodump. So this is what's called a passive analysis tool, and the net of it is that it easily allows us to look up the different stations and the associated clients with each of those stations. So to do this, all we have to do is say airodump-ng and then give it the name of our monitor mode interface. So we come back here, we can say airodump-ng WLAN 1 mon, and we can see we're starting to get all the different networks around, as well as some of the different devices and their associations. This tool is kind of cool. We can go through each of the different networks. We can even look and highlight the different networks and their associated clients. It's a very lightweight thing that allows us to do quick lookups on all this. So we'll go ahead and quit out of that. Right, so the first task we're going to do is hidden SSIDs. So what these are is it's just when the AP doesn't actually broadcast the name of the network in its beacons. This tends to show up as like length 0 in our scans. However, has a pretty severe weakness if this is used as an actual security measure, and that's that any connecting client must use the SSID when requesting to connect. So if we can get just one legitimate client that's looking to connect, we can actually capture the hidden SSID. So to simulate that, I'm going to go ahead and start this on channel 1 because that's what I'm running all of my test networks on. So you can see I have these different networks, and we have this odd one, showing up as length 0. So what we can do is look and see if it has any connecting clients. Currently there aren't any associated clients, so I'm going to turn on my Wi-Fi for my tablet and go ahead and connect to the network. And as you can see, it's actually already been revealed before my tablet has even connected to the network. I go ahead and connect to it, and it's entirely revealed. We can see my tablet right here is sending probes to this hidden network, and it's automatically filled the name in for us as it receives the necessary packets. We'll go ahead and cancel out of that. So now we come to a little bit different of a problem, and that's what if there aren't any new clients actually connected? What if all of our clients are set, we don't have anyone new coming into the network? This problem is pretty easily solved though, because all management frames for wireless, so all authentication and all deauthentication things, are sent in the clear. And so it's actually possible to pretend to be the access point and kill the connections to the clients. So to do that, we're going to use our packet injection tool called aireplay, and we're going to use the deauth mode for deauthentication. Then all we have to do is give it the MAC address of the client, give it the MAC address of the access point, and then say what interface we want to do this on. So let's go ahead, start this again. So now let's say that we have this network that we're trying to discover. We know that there's this particular client attached to it, but it's been some time. It doesn't look like there are any new clients connecting. So we'll come down here. I'm going to do aireplay. I'm going to do deauth mode. Deauth. We'll do 5 just to basically say we want 5 seconds worth of deauthentication. And give it. Go ahead and pause that. We're going to give it the SSID, or I'm sorry, the MAC address of the client. We're going to give it the MAC address of the station. And then we want to say that we put this all through our monitor mode interface. So now I'm going to go ahead and unpause that. Oh, as you can see, we've even already had a beacon. Let's try that again. Okay, so now come down here, and it's revealed for us the hidden SSID. If you were able to look at my tablet itself, it actually basically shows up as like connectivity problems while this is going on, because every time it tries to reassociate with the network, it's bumped off by us until we stop our deauthentication attack. So just a very quick and easy way of setting all that up. Alright, so now let's look at WP. I'm not going to go over this in depth just for time's sake, but essentially all that's happening is that we're creating what's a pseudo-random number as what's called a key stream, and then we go ahead and use that to encrypt our actual data. This key stream is based on a particular kind of seed known as the initialization vector, which is just straight up attached to whatever passphrase we decide to give it. The weakness in WEP, at least the main weakness, is with IV reuse. So this IV, this initialization vector, is only 24 bits long, and that's not really enough to guarantee a brand new key stream every single time. Eventually we'll have some reuse, and because of that we can run some cryptographic algorithms against it to actually crack the password. So if we can get enough of these IVs, we can crack the key. So the process we're going to be, in order to speed up, we can just sit on a network and passively listen for all these IVs coming through. To speed it up, we're actually going to use our packet injection tool using the aireplay mode. And what this is going to do is it's going to listen until it hears an ARP packet. It's going to then try to replay that ARP packet against the access point, and in order to elicit a response from it. Once it does that, it can just replay that same packet over and over and over again in order to harvest more IVs. After that, we're going to use our airodump-ng tool to actually capture everything and write it out to a file, and then we'll use our aircrack tool in order to perform a cryptographic attack. So first of all, come back here. So what I'm going to do is connect to my web network. Just a second. Alright, so my tablet is now connected. See, it's transferred over to the WEP network right here in the SSID. Alright, so actually, first what we're going to do, we're going to kill this, and I'm going to add another option called for W for write, and we're going to say WEP, and that will actually output a capture file for us. So now down here, going to run aireplay-ng I'm going to do ARP replay, do H, go ahead and pause this for a second. Alright, we need to give it the client MAC. So, then tag B, we need to give it the station MAC address. Right, and then we want this to come from WLAN1. Okay, I'll go ahead and unpause this, and now the main thing that we're going to pay attention to is these data packets. These are the things that we really need in order for this attack to work. Okay, so now it's listening for some ARP packet to be sent across the network. For the sake of time, I'm going to go ahead and force it to do so. One second. Alright, so now it's captured an ARP packet, and now it's just continually replaying this. So now we're making bank on all these data packets. So lastly, what we need to do, from here we can see that we have our capture files. So now we can run aircrack, and run that against our capture file. So that will be just our .cap. And we want to use it to attack our WEP network. We'll give it 3. And now it'll start running all the necessary cryptographic algorithms against this. This can sometimes take a while depending on how efficient your network is. I found that a lot of times it will work with around 50,000 IDs, but really it depends. It's non-deterministic in the sense that you never know exactly how many IVs you'll need in order to capture or recover the password. So go ahead and let this run for a bit, and I'll actually speed it up right here. Alright, so we've finished our cracking, and we were able to recover the password. We have here uberleetpass, which, if you look at it, it's really not too bad of a password. It's 13 characters mixed alphanumeric, but just due to the weakness of the WEP system, we've been able to recover it in just over 3 minutes with about 50,000 IVs. So that's that. Please don't ever use WEP. It's a terrible idea. Just don't. Alright. Lastly, we'll cover WPA, which is a much stronger alternative that was developed a few years ago. And so WPA stands for Wi-Fi Protected Access. It was intended to be a much stronger method to replace WEP, and it comes in several different flavors. The WPA or WPA2 is based on what kind of encryption method it uses. The PSK versus Enterprise depends on the exact authentication method used. The most common one that you'll find in a lot of home routers is this WPA2 PSK. Without going into too many details of the exact technical process behind all these, we have our supplicant, which is our connecting client, and we have our authenticator, which is the access point. And essentially there's a whole bunch of information that needs to be passed between these to create a temporary key for us to use for a single session. So that consists of several pieces of information. It consists of the password itself that we use. It consists of the MAC address of the client, the MAC address of the authenticator, the SSID of the network, and these couple of random numbers. We have this A nonce and this S nonce, and all of those are a couple of random numbers that we're jamming into this equation in order to get what's called the pairwise temporal key, which is just this temporary key that we're using. So if we're able to actually listen on this particular connection as a client is authenticating with the authenticator, what we can do is actually retrieve all the different pieces of information that we need to get this pairwise temporary key, except for one thing, and that's the password itself. So the idea behind WPA key cracking is that we first need to get all these pieces of information, and then if we're able to run a brute force attack against it using some word lists, if the word is in that particular, if the passphrase is in that particular word list, then we will be able to recover it. So the capture process is very similar to when we were doing WEP cracking. We're first going to use airodump to listen on a particular channel for any handshakes that are happening. We're going to be using if we need to, we can use AirReplay to deauthenticate the client to force it to reconnect and redo that handshake. And then finally, we're just going to run aircrack with a word list. So you can see that here. We'll get out of here. Alright, so first we're going to run airodump. We want to run on channel 1 and then output to, let's say, WPA, and we want to listen on airmon-ng. Alright, so as you can see, I've created this network called WPA network, and I'm going to go ahead and connect to it using my tablet. So, connect. Alright, so as you can see, suddenly this flag has come up called WPA handshake. Oh, sorry about that. And it also had the SSID of the access point itself. So what that indicated is that, okay, we have actually captured one of those handshakes, and now we're all ready to run a brute force attack against it. Go ahead and look. We have our capture file right here, WPA01.cap. So now what we can do is run aircrack. We want to run it on WPA1.cap, and then we're going to give it a word list. Fortunately, Kali comes built in with several pretty solid word lists. They're located at users, share, word lists. We're going to use the rocku.txt. It's one of the most expansive ones. We want this to run on WPA network. Let that run for just a second, and we have managed to find the password. In this case, it's Hello Kitty. There's just a random one I chose near the beginning of the word list, so we didn't have to wait a couple of hours to find it. But the point is, given enough time and enough word lists, you can recover the password. So I guess the main takeaway from that is, for your WPA networks, make sure to use strong enough passwords. Right. So that's it. Thank you for watching, and hope to see you soon. Bye.